Good. I think I'm going to start for us. The people are starting to join quite quickly now. So yeah, thank you for everybody joining. Welcome to our webinar this afternoon. We're going to talk about from complexity to control and how OnKey can help you to scale smarter in terms of your asset and maintenance strategies. So joining us today for the webinar that we'll be presenting, firstly myself, Stefan Swanepoel. Simon Tron will join us as well, Juan Vermeulen and Maurits Astron. We're all from the OnKey product management team, and we'll be speaking to you about different sections of the product. Topics that we will discuss today. Firstly, just give a little bit of context in terms of where OnKey fits into the bigger industrial software landscape. And we'll talk about generic parts of how the maintenance strategy scaling capability of OnKey can assist you, give some examples, and then we're going to look at more specific areas of OnKey in terms of the scaling and how it works there, and then also touch a little bit on the roadmap towards the end of the presentation. So firstly, when we look at industrial software, this image is taken from Verdantix, a company that we use to consult in terms of software development and industrial software. And just to highlight in this picture, where OnKey is positioned in terms of the different groupings of functionality. So OnKey sits here in the enterprise asset management space. There's some CMMS functionality, computerized maintenance management system, and then also some asset performance management functionality. And if we look at on a scale in terms of operational to strategic level functionality, OnKey deals with everything from long-term strategic planning all the way through to the day-to-day execution of maintenance tactics on operational level. And then similarly on a time scale as well, from to the minute SLAs all the way through long-term year plans. So all those covered in the product. We're not going to go into all that detail today, but just to give some context, when we speak about OnKey, where does it fit into this bigger picture relative to your enterprise asset management system, the ERP, AIP, and other functionality? So in terms of process, what we'll be talking about today is really this whole process of managing your maintenance strategy, from firstly understanding what's in your installed base, having the right maintenance plans in place as a step 2. Then as a step 3, continuously having a full long-term view of your maintenance strategy, updated dynamically as meters and maintenance feedback changes. And then going into a cycle where you would actually now execute on that maintenance together with reactive work that comes through service requests that's logged into the process. And Maurits will speak a bit more about this as well when we speak about the functionality that OnKey provides in terms of work management. So if we look at this picture, typically where your typical EAM functionality would fit in would be there around managing your install base, the part of bridging the gap between the install base and your work management, through your maintenance strategies, and then that work management cycle of planning, scheduling, executing, and closing out on the work orders. So that's the EAM part, the enterprise asset management part of OnKey. And then OnKey also offers functionality in the asset performance management part of the world, where it deals with developing your maintenance strategies, and then also the IoT condition monitoring in-feed into the system, for predictive maintenance and condition-based maintenance, to make sure that you've got dynamic plans that gets executed. Now, looking at all this, and in terms of some of the challenges that one typically faces with having your maintenance strategy executed properly, in the first place, one wants to see that your maintenance tactics and your strategies are really grounded properly in proper failure analysis, and then have that golden thread, from failure causes all the way through to the maintenance tactics that needs to be executed to make sure that your assets operate reliably. Now, if you don't have that line of sight capability, it's often the case that you've got ineffective tactics that's in your system that takes up time and wastes energy and effort, or you might be missing some maintenance tactics that's needed to address some failures that exists typically in your system. So that's the first area that's really important. in terms of making sure that you've got a full, proper configured maintenance strategy for your install base. The other challenge that one often sits with is that, it's all good and well to have these, all the way from your maintenance tactics through to the maintenance execution. Your reliability engineering is playing a role, for instance, at a group level or in a central location. But then you want to also have the ability to decentralize that capability of making adjustments to the maintenance plans all the way through to the actual system owner that's responsible for a particular set of assets. And you want to do that in a way that is still well governed and structured, and that you've got good visibility on where and when that changes takes place. And OnKey really helps to look at all that and make that possible. Next thing that's important, and a challenge that one could find is, once you've got your strategies in place now, to have a continuous future look at what maintenance work is going to take place. And it's all fine and well if it's a smaller installation in a small plant. But when you want to start doing this at scale, for a global install base, having a full picture of your future maintenance work is very important, and it can be quite a daunting requirement if your system doesn't properly cater for that. That all alongside with making provision for continuously adjusting new input parameters, meter readings that comes into place. Sometimes there's different scenarios in which the same assets might be operating in different locations. So to deal with those different contexts or scenarios is a challenge. OnKey takes care of that. And then, now you've got your maintenance tactics and your work orders that's rolled out into the field, but you want to start understanding, are they actually executed within the service levels, and keep track of different role players in that process. If each of those steps, for instance, the planning phase or the execution phase, whatever it might be, if that is actually executed within the time frame and the allowed SLA. So, managing this at scale can really become a daunting task, and OnKey's got really good functionality in that sense to, at the central place, set up these SLAs and make it applicable to the relevant role players in the process. And then the next step, in terms of all what we've spoken about up to now, can take quite a bit of effort to set up. And again, like I said earlier, it's all good and well to do it for a smaller install base. But when you start doing this at scale, that can be quite a lengthy process, and it can take a lot of time. So what we've done, and Simon is going to speak a little bit about this, is various parts of the implementation process we've pre-configured through blueprints and reports and processes and KPIs that's in place to make that possible, and really help you to scale quickly and get quickly off the ground in terms of operating, and getting benefit from the system. Now, all this that I've spoken about up to now, can be quite a lot of information, and we're going to see some of that in one or two of the examples that we show. And making this work at scale, is really quite a challenge. Once you start rolling out thousands of tasks to different assets, thousands of different assets globally, or in a large install base for a big industrial asset owner, and OnKey really takes care of that very efficiently to make it very efficient for people to manage the master data in a central place. Give the ability to deal with standardization centrally, but also deal with the uniqueness if certain asset owners or certain regions may want to put in slight variations in terms of the maintenance plans that they've got. OnKey does that well, and it provides you that scalability and connectivity between the central controlled plans and the adjusted plans downstream. And then lastly, and very importantly, when one starts to deal with these high volumes of data, to have the right system and scalability in place, that this still happens, in a performant way. So system performance also becomes really, really important, when you start rolling out new maintenance tactics from a central location, getting feedback, running thousands of SLAs at any one time. These are all things that's baked into OnKey and been used extensively for a long time. That makes it possible really for organizations to build these maintenance strategies at scale, roll it out, keep it running efficiently, having a good and performant system. If we look at just some example from an asset owner perspective, what we're typically talking about here is you could, for instance, on a generic assembly level, so this might now be at a sub-assembly, you would have done your maintenance analysis, your tactics, understand what's the function of that component, maybe in this case, the chute. There's some failure modes and effect analysis. You set your operating condition options, and you've got your specific maintenance tactics set up now for this particular sub-assembly. Same thing for a motor as an example. And now these components then gets used in what we call a more of generic install base, so a typical asset type. So these would all then be linked to a particular conveyor in this case as an example. And this is then becomes, if you want, a blueprint or a template for a conveyor maintenance tactic. And all these details that's configured here in the sub-assemblies becomes available here with the main conveyor as a type still, which then once you, and this is really where the scaling starts to take place, you can then associate it with multiple actual conveyors rolled out in the field. And all these details that you have to configure and set up, you can do this centrally and quite effectively roll it down to the actual individual assets. And John's going to say more about this, so I won't elaborate too much on it. Linked to this as well is, all the different variables that you can link to dynamically drive the maintenance plans. In the first place, certain parameters that could deal with the configuration of your asset. Maybe it's a vehicle and it is a diesel or a petrol motor, but for the rest it's the same. Then that option could be set to differentiate between your maintenance tactics. OnKey makes provision for this capability that we call conditions. So you could say for different operating scenarios, maybe a high and a low risk operating scenario, and set that. Provide for the options here on the types on the generic sub-assembly side. And then when you go to the actual deployment of the asset, you choose which condition applies. And then it adjusts your maintenance tactics accordingly. So all of these things making it much easier for you to adjust maintenance tactics for specific assets without having to do a lot of reconfiguration. Other dynamic inputs would be meter readings, maintenance history in terms of follow-up, monitoring points for condition, and then task suppression. If there's tasks that should not be done because previous tasks have earlier already been executed. And then lastly, and very important, is this is all good and well in terms of the actual maintenance strategy and the work orders that you now want to get done. But then to get to the actual execution in this mode, will speak a little bit as well in terms of getting that detailed work order instructions in your field engineers or your artisans' hands, where they get instruction how to do the work, and the detailed feedback can roll back all the way to central to do analysis on that work. So all this, can be quite daunting, but OnKey makes it very easy for you. And John's going to say a bit more about, just showing how all that works. Then just another example, this is a typical large original equipment manufacturer, just to give you some idea of the scale that we're talking about here. At the machine assembly level, generic maintenance tactics, maintenance tasks, 64,000 individual tasks here on a type side. And then when you actually roll it out to the actual installed assets in the field, very massive multiplier there of, up to 12 million tasks in that OnKey manages for you by really just managing these much smaller number of tasks on the generic install base side of things. So this is really a picture that summarizes, this massive scalability capability that OnKey's got of managing and dealing with everything that's generic, on the one side, and then, rolling it out to a much larger install base. Right, so at this point, I think I'm going to give over to John. He's going to then go a little bit deeper into what I've just spoken about, and also, just highlight a couple of new features and enhancements that we've recently introduced in this area. So thanks a lot, John. Over to you.
Thanks, Stefan. Can you hear me?
We can hear you well, thanks.
Good. Okay. Hi, everybody. Johan from Yellen. I'm the product owner of OnKey Plus. So I'm going to talk a bit about what we've done lately in how you can customize your physical install base. So, after you've specified your generic install base. But I'm just going to take you through a journey of how you set up your generic install base and the intent of it and how it flows through all the way to your physical one. So in our kind of terminology, the generic install base, you'll see I'll talk a lot about the asset types, kind of the blueprint of the assets, and then on the physical side, it's our asset register, our asset tree, where it's actual assets. You can walk into a factory floor and really go and touch them. So those are the kind of two concepts, and I'm going to take you through just a journey of how you set it up, and then all the enhancements we did the last 2 or 3 releases to give you some more way to customize your physical install base. Thanks, Stefan. Next slide. So the example I'm going to use is just a conveyor belt, and then one part of that conveyor belt is electrical motor. So I'm going to talk you through how you're going to set it up on the generic install base, and I'm going to talk about a library item. You can see it as a subunit or a sub-assembly. So that AC electrical motor is a sub-assembly that you might want to use over and over across many of your generic install base, and then that flows through to your asset register at the end of the day. The intent of the generic install base is really to promote reuse. So that imagine you've got that same motor across thousands of assets. You don't want to go and change maintenance plan on each one every time there's adjustments. You want to do it at one central place, and it should flow through to all your templates, and then from those templates all the way to your physical asset register side. So the example I'm going to use is a conveyor belt and then an electrical motor on that conveyor belt. Next slide, please, Stefan. So your asset type, you can see there on the left-hand side, that's a typical structure, and you'll see also use the terminology library item, which I'm going to get to now. But the library item, it's a subunit. So let's take that AC motor, and you see that I start on the left-hand side. So that's a screenshot from OnKey itself. It's a motor, then it's an electrical motor. It's an electrical AC motor, and then we get to the squirrel cage motor down there. So in that type side as well, there is inheritance where you can have derivatives of that structure. So you could say that an electrical motor generically have got all these maintenance tasks, doesn't matter which one. And each time you make a derivative of it, it inherits all that structure and maintenance plans from the top one, and then rolls it out, and you can further customize it. So what's different to the squirrel cage than the slip ring. But at the end of the day, you're going to draw a boundary around that motor squirrel cage and say, this is my motor that I'm going to reuse in many of and millions of tasks at the end of the day. You're going to try and I see something popped up about unstable connection. I hope I'm still here. You're going to reuse that part over and over again. But before you go in there, as you focus on that sub-assembly, that node, you're first going to do an FMIA or FMICA on that, and then you can also capture within even the FMICA you can capture on the generic install base. That will flow through to the real asset side, which means that if people do maintenance in the field, they can actually have a line back to the origin of what the maintenance plans were, from the start. And obviously from your FMICA, you do the maintenance tasks. And this is all still on your library item, your sub assembly on the generic install base. So you can do quite a lot of things on that side to prepare that little library item or subunit for reuse across your whole system. Next slide, please, Stefan. So if you now I've got on the left-hand side, I've got my subunit library. So I've got a lot of them. It could be motors, gearboxes, air conditioners, anything that you basically are going to reuse a lot. The next step is you're going to basically start constructing an asset type, which will end up as an asset. In this sense, it's in this example, it's a conveyor belt. It's got a lot of parts. It's got the bin loading, the conveyor assembly, chute, a lot of things. And the one thing it has is a motor. So what the type side also has is these placeholders. So you can put down a lot of placeholders. All those items there are component placeholders, asset type component placeholders. You know that a conveyor belt has got all these placeholders, and yet again you are relying on the inheritance from the top one, the conveyor belt, and then you go to the. I'm ending up with a certain model of a conveyor belt, which you can specify some more items there. But I'm reusing the library item, the motor, into that placeholder, which means that if I have 20, 30 of these different type of conveyor belts, all using that same motor, I only have to go to one place and go and tweak the maintenance tasks there, and will flow through to all my MSI templates as soon as I make a change. So if get some learnings from the field and you go and do your FMEA again on your library item and you commit that, it will roll out to all your MSI templates. Next one, please, Stefan. So this is the flow, so from your subunit library, I'm still in the generic install base, to your template. And then, if you then go and create on your physical install base, on your asset register, you've got a plant now. You can see it's a bit more geographic. In this example, it's Europe, Netherlands, Rotterdam. There's a factory there. It's got line 1. On that line 1, there is one of these conveyor systems. And you would put that down there, and then you would say, okay, I'm going to link it to my MSI template. And then that whole structure will pull through. You'll see it's all inherited. And then you're going to see in there is the motor, and that motor actually pulls through all the way from your library item. So yet again, if I'm going to make a change on the library item, it's going to flow through to all my MSI templates, which is going to flow through to all my my assets that's connected to it. So it's really emphasized on reuse, and it's always say it's all good and well if you want to go and tweak maintenance plans on 1 or 2 or 3 assets, but if we've got quite a few clients where it goes into the millions, of maintenance tasks. I think one of our big clients got 25 million of these maintenance tasks across 50,000 assets, and then you want these centralized places where you can go and tweak your library item, and it will at mass flow through all the levels all the way to your asset. So this is the standard on-key functionality. I think you can go to the next one, Stefan. So the next ones, it's not flowing over from my side, Stefan. Let's see where I think I
see on my side, Johan. Yep.
Okay, you can see it on your side. Okay, so the next one, there we go now. Generic install base, so I'm just going to step away now from OnKey itself. I'm just going to try and show it for you in concepts, and which makes it a bit more understandable. So yet again, library item, you've done your FMEA on there. Its intent is reusability. You got your MSI template. That's kind of your blueprint of your asset, and suddenly you can reuse that blueprint across all your assets. Physical install base across all your factories or mines or whatever industry you are in. The changes to the library items will inherit to the MSI template, and in turn, changes to the MSI templates are pushed to the physical install base via the synchronization process. So the system kind of monitors everything that gets changed on the generic install base. And if the person, some people want to do it on demand, other people want to do it systematically. As soon as you initialize the synchronization process, it'll push all those changes through to the actual assets. The next part of the conversation, you can go to the next slide, Stefan. It's going to be, okay, but what now? Things are coming through at a large pace to my real assets. How do I, as the asset owner sitting on the right-hand side, have control over this? And what if I do not, want to subscribe to changes? How can I disconnect from that changes? Can I, may I? And what options do I have? So these are a few things that we've added in the last few releases. The first one is an old one. You can so I'm just going to go through this. It's the options you have is custom entities, unsubscribe from the MSI template changes, resubscribe and resynchronization conditions, and workload alignment. So the unsubscribe, resubscribe, and the workload alignment are the 3 items we've added recently, which I'll go into a bit more detail. Next slide, please, Stefan. So the customization is, as you see, that motor, that library item came through with all its, parts and maintenance tasks, and it lies now there on your, on your asset side. But nothing stops you from customizing that and putting your own items there. You can put in components, maintenance tasks. You can, anything you want to do, and you'll see that difference is that the ones at the bottom's got the little purple inheritance symbol on it, where your custom ones are just visualized without that. So you can very easily identify which of my maintenance task or substructures is stuff I've customized, and which are the ones that are listening to changes from the type side. So yeah, nothing stops you from customizing your asset, and break away a bit from the blueprint that gets proposed for you. The unsubscribe is where you would say, okay, I'm happy. So say plant A, plant B, plant C. So all of them got the same conveyor system. But the person in plant C says, I'm happy with starting off with my blueprint from my MSI template, but I want to customize it further because I'm in a very different environment and I need to customize maintenance tasks. I need to customize my structure, add more things. I don't want it to be overwritten from changes from the type side. So in that case, there's a feature you can use, which is called unsubscribe. And you just stop listening to changes from the type side. It's still inherited to that side. So you can still go and look, what was it originally, what changes has been suggested since then, but you kind of disconnect yourself from the blueprint and you start, walking your own journey on maintaining that asset. Then what you have is you can then start listening again. That's the resubscribe function. So you just connect it again. You can see that last arrow, it's a solid line again. So you just start listening again, but you didn't get the delta or the changes that would have come through since you switched it off. You won't get. So you will just then start listening again from the day you switched it on, and any changes that then are proposed from the type side, you would then get those changes. But then you got clients that says, okay, I want to start from scratch again. I want to resynchronize. So that's kind of when you realign your asset again to the MSI template. Any objects that you've customized, so custom components, custom tasks, that'll remain. But the ones that are still linked to the type side will kind of realign again and then start listening again for changes. So we just had many clients that says, I don't want this forced changes on me the whole time. I want to sometimes disconnect. And that's the functionality we've added the last few releases. Next slide, please, Stefan. So the other thing is people want to tweak frequency of tasks, and that's the conditions. Okay, so not structure. They want to just, I'm happy with my maintenance tasks, but I'm in a different environment. I'm in a desert, dusty environment, and I'm using products through my system that's very abrasive. So I need to maintain my certain assets more aggressively than others. So we've got this concept of conditions. You can think about any condition that's applicable to you. It's not hard coded. I use examples there of risk, temperature, and product. You can add as many as you want, and you can apply as many, active conditions on an asset. It just kind of sums it up. So, you say plant A you could put or choose active conditions of high risk, medium temperature, medium product. So it's I want to run high risk because I've maybe got redundancy. So take that frequency of the tasks and stretch it out a bit. I don't have to maintain these certain assets so rigorously, because if something breaks, I've got enough spare parts, I've got enough redundancy, I've got duplication or triple of these things in my store. Where say plant C, he wants to go low risk. Okay, this asset is very critical to him. or to her, and they would then choose a low risk strategy, which means the frequency is close to each other. Maybe it's in a high temperature area, so that's more strenuous on the machine. And maybe they're also working with abrasive products. So suddenly their frequency of a maintenance task is much, yeah, the task needs to be done in a much more frequent way. So that's also a way for the asset owner to adjust frequency. With the top ones is I want to listen and not listen anymore to changes, where this one is tweaking the frequency. Next one, Stefan. Then we got now now we're jumping more to Maritz's side. Now, you got your blueprints. They pushed out maintenance tasks to your asset. You've tweaked them the way you want. And as those tasks are being added to the asset register, the background, a lot of due tasks are already being generated. That's a nice part of the system as well, is even before you run your proposed work orders, the system automatically runs a due list at the back for about 3 years, 4 years, however far you want to look advanced. So the system is always has a year plan or a 2-year plan of maintenance tasks ready for you to run on reports. So as soon as you tweak a condition or add a task, those due tasks are already there. But let's jump now to the work order side. So now you have your physical install base, you've got your asset register, you're very happy, and the system starts pumping up job cobs, work orders. And people got different rhythms. What we found is that some of the larger organizations, which they need to organize a larger workforce. So they start running proposed work orders and work orders very far in advance, sometimes 6 months in advance, because they need to start planning and getting the workforce ready for that long before that. And while that work order is now proposed 6 months ahead, in that 6 months, a lot of changes has happened on the asset register. An engineer has decided that this maintenance task is not required anymore, or a spare part has changed, with the old one to a new one, or the resources that's required has changed. Many things can change on that asset from when you put a peg in the ground and predicted the future. And that's what we added also in the previous releases, is a way for you to realign your work order to your asset register. So, work orders that's been there for 6 months and now it's getting to the point where the work needs to be done, you can multi-select those work orders, realign them, and it will go and look at the asset register and say, okay, is this task still valid? If it's not valid, we make it disabled. Are there new spares that are on this item? Yes, there are. We add that. Is there any changes to the resources? So it kind of, it saves you money, potential money, where people might have had to go and do work, and now it's not required anymore. Or the other way around, the more critical items have come on, and we need to basically add them. Another thing is, as well, with realignment, we look at suppression. So obviously a lot of reality happens on the work order side, where people merge work orders or split work orders. And we can also detect, that just before you do the work, and say, should this task be suppressed? Because maybe there's another task on here, which is actually, if you do that task, you don't need to do the one next to it. So you can save quite a lot of money on that. So it's a system trying to give you options to keep you aligned with the reality of today. The next one, Stefan. So just as a overall big picture, you got your library item, did FMEA on it or FMEA on it. You've built your MSI template. It's all reusable. You've got many assets across the world. It could be 2 assets to 2,000 assets with a lot of maintenance tasks. You've got the options to tweak those physical installed base with quite a few things we've added, all the way to the work management, where you can also align it to the reality that's happening currently. I think that's it, Stefan.
Yeah, thank you, Johan, and thanks for the excellent summary. And I hope the message came across really, that what OnKey provides to you is this ability to, in a central location, set up a lot of master data and information that that can be very efficiently rolled out to a very large install base. And, with other systems, that can be quite a daunting task to keep all of it aligned. But a lot of what Johan has explained now is really the system helping you to keep all these different parts in check with each other. And also, if there is the need for variation, that's still done in a controlled way, that you don't lose control over it. So it makes it feasible to really have fine-grained maintenance tactics developed centrally, rolled out, to quite a large install base in a very efficient way. So,
maybe
do you want? Yeah.
Maybe two more things, Stefan. The one is there's rich control, because obviously if you do changes in that library item, you can affect quite a lot of assets. So we got quite a rich we call it development statuses, where only certain people can accept and push those changes through after somebody proposed it. Okay. And the next thing is, as soon as you work, it just dawned on me, as soon as you work with many, I'm talking about thousands and millions of records, the visual tree doesn't help you anymore. Then we start going over to dashboards, and now dashboards have got a lot of richness in the query builder functionality. That's for you to draw up profiles where you can monitor these things at scale, and where it shows you things that are out of sync. So people start actually moving as soon as they work with millions instead of thousands, instead of tens. They start moving to our dashboards and use the query builder and the query language to really see the data quickly, and have and control it from that point of view.
Excellent. Yeah, guys, and thanks so much, John. Yeah, really, really well communicated. And if there's any questions later on, hopefully we've got a little bit of time to delve into that. And if there's questions, I didn't remind you guys, you're also very welcome. There is a Q&A part to the webinar that you can just type your questions and we'll try and answer it as we continue. So now this is now the plans and the maintenance tasks that needs to be completed, and now we're going to look at the actual work management part. And Moritz, if you're ready, you can take it away for us and speak about how we deal with that actual work execution. It's no good to have great plans if we don't execute on them. So that's what we want to look at now.
Perfect. Thanks, Stefan. I'm going to assume you guys can hear me well. I think we can go to the first slide, or the next slide, Stefan. So shown here is the 9-step work planning and control cycle, which is traditionally followed. First, we see the top left, we see work being identified using predetermined calendar schedules, usage-based maintenance, reactive work, or condition-based maintenance. Then quite an important step is the validation step, to ensure that work isn't duplicated, assets aren't over-maintained, or reactive work isn't done on assets that are still under warranty. Then we go to planning, which includes identifying and procuring any materials and resources that might be needed. Work is then pulled from the backlog and scheduled into a week and number 4 there. Then daily allocation looks at the available resources in the team and assigns the work to the right people. Then everyone should be familiar with execution, as this is where the rubber hits the road, and the actual maintenance is performed and the data is collected. So just when we look at the maintenance, you can see there that we're talking about tasks and subtasks that need to be executed, failure analysis, whether that's global analysis or if Mika, if you went through that process, collecting meter readings, collecting monitoring points, and then there's material usage as well, which can include things like requisitions. Then the feedback is normally documented during or just after the execution, and then steps 8 and 9 are sometimes done interchangeably, but the feedback is analyzed and then captured, or captured and then analyzed. We can also see a couple of kind of shortcuts there for immediate work that's identified during the identification phase, which is then just executed. Typically, when a breakdown happens on an important asset, urgent work can be expedited to the daily allocation, and then based on the feedback that's then analyzed, we can create follow-up work, which then goes into this entire process again. Thanks, Stefan. Next one. So what we're seeing nowadays is that a lot of condition-based work identification is done using IoT sensors. This is especially useful in detecting potential failures before they happen. However, since sensor data is sometimes unreliable, Anki can first trigger alarms for someone to go and have a look, or the alarm can have a work order, which can then be prioritized and allocated to someone to go and validate a reading or readings that were captured. Anki also has the ability to combine multiple sensor outputs to calculate complex values, such as the relative saturation that's shown there in the screenshot. This is also useful if a reading has to be considered within the context of another reading or other readings. For example, the temperature of a component or a subassembly or a specific sensor in conjunction with the ambient temperature. These combined readings can then be evaluated and work orders can be created if a specific threshold is exceeded. Thanks, Stefan. As Joan mentioned, at some of the larger OEM clients, scheduled work orders need to be generated long in advance to ensure that resources and materials are ready by the time that work needs to be executed. This can, however, mean that work orders are for an outdated configuration of the machine, or that some of the tasks on the work order have been altered on the asset or asset type side and need to be adjusted. The new functionality in Anki can be used to realign the tasks on the work order with the assets configuration. As I mentioned, this was well explained by Joan, but quite an important area if you want to make sure that the maintenance that's being executed is actually accurate and aligned with what was planned on the asset type side. Thanks, Stefan. In the modern day, we also see a lot of execution, feedback, and capturing steps are actually combined as technicians are completing work with mobile technologies, optimizing interactions with the mobile application and serving technicians with the right contextual information while completing the work means that we've got more effective use of their time. We have recently updated the Field Engineer app and made a lot of improvements to minimize the number of touch points in the Field Engineer app when the readings are being collected. So this is both for things like meter readings and for monitoring points. We're now showing you previous monitoring points and meter readings. So let's take an example of an odometer. So if the previous reading was 1200 hours or 1200 hours, if someone wants to enter a reading that's 120, it's quite obvious that is probably not the right reading. Or if the reading was entered a long time ago, let's say your new reading is 4000 hours. If the previous reading was 1200 hours, but it was 2 years ago, I guess that's quite possible. But if the previous reading was, let's say, 2000 hours ago, 2000 hours less than the current one, then it's obviously a mistake. So we've tried to put the contextual information in the hands of the technician to make sure that the data that's being entered is actually accurate. And then, as John mentioned, the meter readings can then be used to make sure that upcoming usage-based work is proposed at the right time, and that monitoring points can be used to trigger follow-up work orders, as I mentioned in the previous slide. Thanks, Stefan. Last slide, I think. So to bring all of this back to OEMs, I think as we've kind of stressed a few times in this webinar, the big benefit of using a system such as Anki with the asset type and asset functionality is that you can analyze feedback on the same component or subassembly in the library across tens of thousands of instances of a component or subassembly in the physical install base. So the major benefit of this is, of course, that you can look at failure patterns that are not addressed by your maintenance tactics, and equally importantly, it allows you to also remove or decrease the frequency of inspection tasks which never fail, thus saving you time and money. So I think this is something that is obviously quite often overlooked, is we always just looking at adding more and more tasks to prevent failures, but I think we never do the optimization where we look at the install base, see that the specific task is being executed or it's been executed 10,000 times and it maybe failed 5 times, then we could probably increase the frequency or reevaluate whether what we're measuring is actually giving us proper results. I think that's it from my side, Stefan.
Excellent. Yeah, thank you, Maurits. And maybe just to re-emphasize, all that details that Johan spoke about, lots of detail to deal with and to get to the actual maintenance execution people on the ground. And this is really where the strength of this work management process with the mobile app comes into play. And getting that detailed work instructions out, and then also detailed feedback, as Maurits just said, now back into the system. And all that done without a lot of manhandling, because the system takes care of the most of it for you. So, and from there, the scaling ability that we wanted to emphasize. So thanks a lot, Maurits.
Yeah. Exactly, Stefan. And maybe just a last comment. I think, especially in a big physical installed base, the original work that you need to do, and Simon's going to actually touch on that now, seems like a lot of effort, but if you use it effectively, then the benefits that you get from a system like OnQ, I guess any big enterprise asset management system really reaps rewards, because you can bring everything together and then optimize, and really in the long term make everything that you're doing more effective and cost effective as well. Thanks, guys.
Absolutely. Excellent. Thanks, Moritz. Simon, I see you ready. So I'm going to switch over to your side then. Thanks. And you can just tell me when you need to step off.
Thanks, Stefan. You can switch to the next slide. Right. We have packaged industry-specific as enterprise asset management solutions. These solutions have been pre-configured and they are ready to be implemented. The first implementation blueprint is aimed at our clients in the commercial facilities industry. This includes, but is not limited to, retail, hospitals, hotels, and real estate. Thanks, Stefan. Our second implementation blueprint is aimed at asset-intensive industries and OEMs. These include mining, heavy manufacturing, and oil and gas clients. And finally, thank you, Stefan, we have packaged the solution for our asset or application management services. These are custom solutions where Pragma assists our clients' maintenance team to maximize OnKey's benefit to their organization. Okay, next slide. Thank you, Stefan. One of the strategy management scaling challenges that Stefan touched on earlier was around efficient implementation. And our implementation blueprint standardize implementations by eliminating inefficiencies, thereby accelerating time to value. By standardizing our implementations, the project team is empowered to implement the solution confidently, and I think most importantly, also to allow for value-adding activities. So these blueprints comprise three main elements. Firstly, an industry-specific pre-configured template database, facilitating the implementation of an accurate asset register that is easy to maintain. Secondly, a standard, efficient work management process that is executed with the use of mobile apps. And then finally, a step-by-step how-to guide on how to configure OnKey and the apps to be used by our project team and our partners. Thank you, Stefan. The next slide. Firstly, with regards to the configured databases, here are some of the main entities that have been pre-configured in our blueprints. Firstly, asset type folder structures and asset types with asset care plans or tactics. Clients are presented with a library of asset types to select from, and the tactics include statutory tasks with follow-up tasks for inspections. Thanks, Stefan. Next click. Work order statuses and work order allowed status are pre-configured, and this drives the flow of work orders through the system. And then finally, Stefan, you can click. Types of work, including type of work, sub-classifications have also been pre-configured and are ready to be used. Next slide, thank you. One of the big pain points for our clients and our implementation teams have traditionally been user access management. There we've made some massive improvements, and this has all been pre-configured and packaged in a way that saves time and effort. Operational roles, security roles, permissions, user interface profiles, and main menu views are all pre-configured in the blueprints, ready to be linked to the different client personas. And in addition to this, and in support of the entities that I described in these last two slides, various other entities have also been pre-configured in the blueprint databases. These include asset importances, task importances, work order importances, task intervals, standard tasks, cost elements, currencies, calendars, units of measurement, and many other entities that do not need to be configured at the time of implementation. Thanks, Stefan. The pre-configured databases also include engineered KPIs, reports, and dashboards that are based on asset management and industry best practices. Thanks, Stefan. Then moving on to the standard work management processes. For each of the industry blueprints, we have developed a streamlined work management process showing the main steps of the process. You can click, thanks, Stefan. And then also a detailed process flow chart and supporting material describe the entire work management process from generation through all the statuses until closure. Next slide, thanks. And then finally, the implementation blueprints contain detailed step-by-step how-to guides to configure OnKey and the applications for our clients. From the requesting of software through the configuring of the staging environment, authentication, importing of client data, generating QR codes and configuring users, and then finally configuring the production environment. And then lastly, thank you, Stefan. Role-based training packs are also available for the requester, the planner, the supervisor, contractors, internal technicians, contracted technicians. We also have video sets detailing each step in the work management process. And this can be used for overview training or for marketing purposes as well. With all of these elements in place, projects can be rolled out efficiently across multiple client sites, making it much easier to scale our projects as the client's business grows. I think that's it, Stefan.
Excellent. Yeah, thank you, Simon.
Thanks.
I think that's it. Yeah, and maybe just to highlight again, you know, back on the theme of scalability and quick time to value. These you can clearly see there's a lot of configuration and possibilities with OnKey being such a configurable and broad platform. But through these blueprints that Simon, you know, and the team created, really very quickly to get off the ground. And Simon, I don't know if you want to quote here, but I mean, we've had instances where clients, you know, within 2 weeks, 2.5 weeks, managed to implement quite complex solutions using these blueprints. So really speeding up things quite a bit and, you know, getting you off to a good start to efficiently use the system. So, yeah, no, brilliant work here, and I look forward to more additions in this area. Guys, and then maybe lastly, I'll just very quickly, you know, just to keep you also in touch in terms of what's happening and if, you know, other things that we're busy with that's coming up in terms of the roadmap. Just a few areas to touch on. Something that will be landing quite soon now. John, it's going to be version 17 coming out very shortly now. Is our asset performance OEE management module that will now also become available in OnKey Plus. We are at work in analyzing and, you know, refining the details for a contract management capability, you know, within OnKey. We've been dealing with that for a while, you know, through use of work orders and tasks, but this will be a more efficient and fine-tuned method of really dealing with, especially the processes around quoting and invoicing, etc., for contractors. Important capability that we will really be sinking our teeth in very soon now is the management of rotables, as we call it, or repairable sub-assemblies. Very important, and lots of working capital tied up in those, you know, warranties and unrepaired sub-assemblies that this module will help solve. And then maybe a bit more on the architecture and back inside things that we started to put in place. Certain clients, you know, want full access to their full data set, you know, that's in the OnKey database. But us hosting the solution for clients doesn't make it possible to give them raw data access to the databases that's under our control. But through this data replication service, we can now, you know, replicate the database out to a specific target for the client, where they then have full access and deep access to the database, you know, for data analytics purposes, and whether they want to use it for AI training purposes or other BI processes. So that's something that's in the works. We're also getting ourselves ready to, you know, to fully support clients with integrating OnKey into their enterprise landscape for AI purposes. So you can already do this if you work directly against the OnKey APIs, the programming interfaces. But what we'll be putting in place, the architecture team will be, you know, a proper MCP service, which is the standard way for AI agents to integrate with systems like OnKey System of Records to make sure you still have good controls over which data can be accessed, and not keep all those security measures properly in place. And then another important something that we're quite excited about, and we'll be spending more and more time on, going forward, is the user experience of the product. There's a number of areas where we realize, there can be fewer clicks and certain information can be brought together more effectively. So we're embarking on a project really to deal with this and make Anki more efficient in that sense. And simultaneously, we'll also be looking at, as things like AI and large language models and different ways of interacting with the system comes into play, also address that, future Anki would be a system that you don't just click through menus and enter field data in forms, but that you can, in a more conversational way, interact with the system to get data out of it. So just a few highlights. There's a couple of other things as well that we'll be working on, but a few that I thought to mention. In the next months, that's highlights that we're looking forward to. Right, so yeah, there's 3 minutes left, guys. I didn't see if there's any questions that came up that we need to deal with. I don't see any. Maybe if there's any last minute thought or a question, thanks for people that joined. Really good to have you here, and for those that perhaps couldn't join during the session and listening later to the recording, thanks for joining, and please be in touch, with any of us or through the marketing team, if there's questions that you'd like to get answered, and really see how Anki can help you. If you're a large asset owner wanting to standardize, wanting to have good control over your asset information, and are a bit worried about how it will scale, hopefully this shed a little bit of light in terms of how that could be possible. Or for service providers, original equipment manufacturers that want to go on a servitization journey, see how Anki can help you in that, in terms of managing that big install base with the maintenance strategies and everything that goes with it. Thanks for the team for the preparation and sharing the information. And wish you a good afternoon, and for those that maybe joined from other time zones, good evening or a good morning. Excellent. Thank you.
Thanks, guys. Bye.
Thank you. Cheers.
Bye.